Hi there. In this screencast, I'm going to be explaining how to use the NC functions for um, capturing and melting different columns of data frames. So the classic example that I like to use is the iris data. So the iris data, everybody's favorite in R, this is a data frame with 4 numeric columns and one character or factor that, yeah, it's a factor that tells us what is the species of each observation. And so, one of the things that you might want to do in R is to make a plot of all of these numbers. For example, you have the sepals and the petals, you have the lengths and the widths, and maybe you have a question like, what do the sepals look like relative to the petals? Or is one bigger than the other? How would we answer that question? So one way to do it is to make a data visualization. So we might want to use ggplots. I'm a big fan of ggplots. So if we use ggplot2 to answer that question, we're going to end up writing ggplot code that looks like something like this. For example, if we want to use a geom, how about a geom histogram? Is that right? So, we're going to use something like, AES centimeters, color equals species. Data equals, maybe let's call this iris tall. And so, we have some, maybe we want to make a fast set wrap for every different value of this, for every one of these variables. So here this assumes that we're going to have some data set where we have 3 columns, centimeters, species, and variable. So how are we going to get our iris data into that format? Well, one way to do it is using NC. So NC provides this function Capturemelt. Let's start with Capturemeltsingle. It's a little bit less complicated. We'll see this multiple in a future screencast, but here we have Capturemeltsingle, and what this does is it's going to convert a bunch of different columns in like wide format, like we have here with the iris data, to this kind of tall format that we want to use this data visualization. So here we can, in Capturemeltsingle, what you do is you provide that wide data table as the first argument. And then after that, the rest of the arguments are interpreted um, as the regular expression pattern, which is going to be matched to the column names. So, so what we can do is we can just say match, part equals something dot, dim for dimension equals something else dot star will match anything. So this pattern is going to match anything and then a period and then anything. So it's going to match all of those 4 column names except for species, right? So if we do that, we get, well, we need a comma, but if we do that, what we get is we get this data table with species, partdim, and value. And so if we want that additional column called variable, well, what we can do is we can add in another pattern, variable equals list, all of this other stuff. And so that's going to match everything inside of the other patterns. So you see that we now have a new variable pattern. And so if we save this in our iris.tall, we can plug that directly into our ggplot that we just have over here, right? Except for here the value column is not going to match up with the centimeters column. So if we want that, the name of the value column, this is provided by default. But if we want something different than the value name, we can call it value name equals cm. And here now we have the iris tall, which indeed has a cm column, centimeters column, that we can throw into our ggplot. Let's take a look at that guy. Plot is missing variable. Layer 1 is missing variable. Is that right? Oh yeah, well, so we forgot a plus sign here, so let's do that. But yeah, so check this out. So here now we have data visualization that's comparing the length, the different variables in different panels going around. So here I was doing color equals species. Maybe it would be better to do fill equals species. I don't know. That's all right. Another thing that we can do now that we have these other columns, right? So we were just faceting based on variable. We can also use the part and the dim, which are extracted into separate columns with a facet grid instead, right? So let's try that. So here, if we do facet grid, you know, here we have the different parts on the rows, and we have the different dims on the columns. So if we wanted the opposite, maybe we have dims on the rows and parts on the columns, we would just go like this. Right, so there we go. Then we get a facet grid layout using using ggplots pretty easily with this manipulated data. So yeah, I mean, you're maybe familiar with functions like Capturemeltsingle and other packages. It's meant to be similar to the melt functionality of data table, and in fact, it uses data table internally, but it provides a nice syntax for using using it. So again, you know, when we're doing this, all we have to specify is the regular expression pattern as these in these arguments, and what we get then is we get what's essentially happening is we're calling melt on the initial data table. All of those column names that match the given pattern are being melted into this into the centimeter column, and then we're creating some additional columns based on the names that we provided in the regular expression pattern. So all of the values from the captured column names of the input are going to be present in the output data table as additional columns in order to facilitate interpretation and here plotting. So hopefully that was a interesting demo of Capturemeltsingle for you guys. Thanks for listening.